do is looking at very specifically distance time graphs. And our goal today then is to be able to look at a distance time graph and interpret it. And this I like because we do this right at the start of grade 11 physics or grade 12, 11 university level physics or grade 12 college physics. We spend a lot of time on this very topic. So I like to know that we spend time on it in grade 9 as well, so it's not brand new in physics class. So if we had a distance time graph, now this looks crazy, and by the way, no line of best fit on this one, but we want to be able to look at this and sort of interpret what's going on. And the letters here just refer to sort of points in time or being able to split up the graph. So, you know, A here refers to this straight portion, the entire straight portion. B refers to this horizontal portion. C is this negative slope portion where it's heading down. D looks to me like this flat line, and E is this curve. Okay, so what I mean is, you know, A goes from here all the way down here. A is this whole time frame, which looks like about, this is time, so this whole 5 seconds. Okay, now if we're looking at this graph, and this is distance meter, and that might be meters north. Someone's walking north, okay, and I think it's important enough to include a direction. So I'm going to say north for this. Okay, so we want to interpret, I kind of wish I hadn't done that messy line right there, but okay. We want to interpret what's going on in this graph, and I'm just going to give you the first little run through underneath. Okay, so in this space here, we're going to write down, you know, what's happening in section A. And I'm just going to tell you first, and then I'll let you see as we go through the rest of the note how that works. So in section A, what I see, straight line means constant speed. So section A is moving at constant speed for 5 seconds and moving north. Okay, so that's what I would say is happening for the first bit. I'm going to make that much smaller and easier to read. Red. Okay, so that's the first little bit. That's section A. Moving at a constant speed for 5 seconds in the north direction. In B, don't write this, I'm going to delete it. In B, if you look, his position, his distance from wherever he started, it's at the same spot. It's at, say, 9 meters. And it sits at 9 meters. So section B, he's not moving at all, right? He's staying at the same distance from wherever. So staying still. Okay? C, he's moving back. So say he started at home, right? Moves away 9 meters, stays still. C, moving back towards home. Okay? So this negative slope means heading backwards. So part C here, I'm going to say moving at a constant speed. It's a straight line. South. Okay? Because we said that they're heading north here, so now he's moving back a little south again. Okay? D looks like staying still, so we'll just copy and paste that over. Stops for a minute. Okay? Not a minute. He stops for 20 to 25 seconds, about 5 seconds, right? And then here, this curved section in E means that he's speeding up. So he's at a stop, and then he starts to speed up, and he changes speed. Okay, so this refers to what in physics the term is acceleration. So whoever is accelerating in this point, speeding up, changing speed. Okay, so a straight line means constant speed, a curved line means changing speed. So in E, speeding up, moving north. Okay, so every time that the graph is going in this direction, in the up direction, that's north, and anytime he's moving and it's going in the down direction, in this case, it's south. That's because I called this north. if this had been south or east or west. It could be anything. But once you decide which direction is on this axis, then anything going backwards is in the opposite direction. Okay? Okay, so some important notes. In a distance time graph, time is always the x-axis. Okay, always. And that makes it what we call the independent variable. Independent means you can't affect it. And from our point of view, you can't affect time. Time is the independent variable always. Okay? Distance, in this case, is always in the y-axis, and it's the dependent variable. And what that means is, more time means you travel more distance. So distance is dependent on what time it is, whereas time is just a constant. It just keeps going. Okay, so what the different looking graphs mean. If you have a straight angled line in a spelling error, positive direction, okay, so it's sort of moving up, that means that it's moving at a constant speed. So straight line means constant speed in what we call the positive direction. Like in the last example I said that was north. If it's heading down, that means it's moving at a constant speed in the negative direction. And again, the idea is that if you say north is positive, then south is negative. Or if east is positive, then west is negative. It's moving the opposite direction. And horizontal means not moving. Curved lines mean changing speed. And you're either speeding up or you're slowing down. Okay? And what it looks like is sort of the steepness of the curve tells you how fast you're going. So here where the curve's really flat, that means that you're basically down to 0 speed, right? And here where it's really, really steep looking, the steep looking means you're going very fast. Going very fast, now you're slowing down, probably at a stop. And this is the exact opposite. It's horizontal, so you're kind of at a stop, and then it gets more and more steep, means it's going more and more fast. Okay, so what if we want to make a little story out of this graph? And this graph is the one we looked at the beginning, and we'll call it Ferd's journey. What does Ferd do? And you can make up anything you want, and you can expect to see some sort of question like this at some point on a test, or not test, or on your assignment. So say we have our Ferd going on a trip, and here's how I would look at it. He walks for 5 seconds at a constant speed, moving 9 meters. Let's just look at that. 5 seconds here, and he moves 9 meters. And the straight line refers to constant speed. He stops to pick up a penny, which takes 10 seconds. So here he's at a stop for 10 seconds to pick up a penny. He then turns around to pick up another penny he saw behind him. So he realizes as he picks up this penny that, oh, there's a penny back here too. So he turns around, walks at a steady pace, gets to that point, picks up another penny, and he's at a stop here. Okay, I'll leave this on now so you can keep writing. He then turns around to pick up another penny he saw behind him. Then he remembers he is late, and he sprints, speeding up towards home. Okay? So you see his acceleration at the end. So that's just a little example with distance time graphs and being able to interpret what they mean. And that's it. That's the last note for this unit.